This is a potato demo by Medius.Re, where we will look at the analytics feature using data available through Potato USA's use of Medius.Re. Okay, let's go ahead and look at the analytics feature that's available in Medius.Re. So again, we're going to go over here to our trial groups to snack chip trials. And instead of clicking on trials, we're going to go ahead and click on analytics. And let's also again come up here and shrink our sidebar so that we have more room to work with. So the first thing you want to do is make sure that you have your trial year set to the year of data that you want to look at. So we're going to go ahead and keep it at 2020, which is the latest crop year available. And then I'm going to go ahead and select the data fields that I want so we can begin. So let's pick specific gravity. We'll look at yield total, yield number 1 within field data. And then I'm interested in defect external and internal percentages within process data. So now that I've got those selected, I can just click off of that and it's going to tell me I need to rebuild my analytics because I've made some changes to the data that I'm looking for. So I'll go ahead and click that. What it's going to do is it's going to fetch that data. It's going to build the analytic calculations and then render the table for you. And depending on how much data you're pulling back, you'll see a variation in how much time that takes. So what we're looking at now is we're looking at here these 5 data fields that we had selected up here at the top that show you field data, specific gravity, and then you can see the process data here. What this little -1 indicates here is where this value is inverted when it comes to z-scores. So you ask, what is a z-score? Well, z-score is the number of standard deviations off of the mean. And we use that z-score to help us see correlation between each of the data fields when we're building this total score averages tab here at the end, but we'll get to that in a minute. Let's go ahead and look at how the data is broken down here in analytics and how that can be useful to us. So what you're going to see here, at least looking at the Potatoes USA data, is they have each one of their trial sites listed here, and they're grouped by these groupings of storage and fresh locations. So what this allows me to do is I can see the values for specific gravity across each trial location, but then over here at the end I can also see the average of that variety's specific gravity grouped by the storage and the fresh and also the total. So what I can do, I can click on any one of these headers if I want to sort the information that's available to me. So I clicked on total here and you can see that it is now sorted top to bottom. So let me explain a little bit about what we're looking at as far as colors are concerned. So whenever you see the green here, that is the, in this particular case, that is the max value. And when you see the red, that is the minimum value. And anything that is shaded in this orangish yellow is going to be below average, and anything that is shaded in this blue is above average. And we define above and below average in this shading here to indicate these are the values that are above the mean, above the average. So the average here being 1086. These averages here are currently just in are grayed out, and then we have the gradient shading here for stuff that's above and stuff that's below average. So then we come over here and we look at this piece and we've got these maximums and these minimums and the below and above average over here as well, where there's not a gradient. And what we're looking at there is this is giving you indication for the above average, the blue, where there's values that are greater than or equal to 1 standard deviation above the mean. And the below average is where it's less than 1 standard deviation below the mean. So this gives you a quick look to see what are the top performers, the bottom performers, and where are my variations in the middle. I can jump here to yield total and you'll see a little bit more variation due to the nature of the data. So you can easily see here I've got some above average performers and some below average performers, as well as my top and my bottom. There's a couple different ways that we can change how we're viewing this data, and similar to when we went to trial settings, we have analytics settings up here. So let me go ahead and click on analytics settings, And you can see we have the standards in here again, so you can turn that on and off. If you're interested in seeing the z-score, so like what is that z-score value that is driving the shading and is driving the calculations, you can go ahead and turn that on and it will show you those values underneath the actual data field value that you're looking at. This could be beneficial if you're trying to understand more of the details behind the data. I'm going to skip these two at the moment. Let's jump down to show gradient, because what I want to show you is if I turn this show gradient on, you'll notice that this averaging went away down here. If I turn it back off again, you can see that that shading legend disappears, because now we are looking completely at applying this legend that is typically what we see in these averages across the entire spectrum here. So now if I were to sort, let's say, Michigan, I can see now my gradient effect of the values that are above average. The true average of 513.3 is right here in between these two, the Snowden and the MSZ 063-2. So I can easily see how far away, the darker the color here, the darker the color here, the further away from the average the value is. And so that can be pretty handy if you want to get granular at looking at a specific trial site. I'm going to go ahead and turn that off though. If you just wanted to completely get rid of colors, you didn't care about the colors and you wanted them hidden, you can turn colorize off and just look at the values in a table format. But let's keep those on. So, okay, I skipped these two. Let's go back to them, the multi-year average. So if you remember right here, we have just the current year's average, the 2020 average. But it can be beneficial to look at how a variety performed compared to other varieties within specific trial locations across multiple years. So I can increase this to whatever I want. Let's say 3-year average is probably a good idea. And I know from working with this SNAC data that these varieties go through a 3-year program. So there isn't going to be data available past the 3 years for any of these varieties other than your check materials. So let's go with 3 years. And then I'm going to go ahead and click on this little refresh icon so that it can go fetch that 3-year data and pull it in for us. Okay, so now here what we're seeing is we have these 2020 averages, but we also have the 2018 to 2020 averages, which gives us a lot more indication to a variety's performance over time. And I can sort these just as I would have sorted any of the other columns, so I get good indication as to how that variety performed over multiple years. So you're going to see that there's some Y's and some L's over here. And so looking at the Y's, that is how many years worth of data is represented in this average. And the L is the number of locations that are represented in that data. So for example, this variety here, Lamoka, you can see that this data is comprised of 3 years worth of data. So it's across 3 years, and it was tested on 26 sites. So that gives you some indication to how much depth is a part of that average, and just helps you be able to compare. So as you're looking at something like this MSW 474, okay, it was trialed across all of these locations, which is really good to be able to get a broad scope and a broad look at this variety. But it's only for 1 year. So there could be some things that we need to keep our eye on that may come up in the next 2 years. Whereas Lamoka, we're looking at all 3 years worth of data that we selected in 2018 to 2020. So let's go ahead and say, all right, these are the data fields that we care about, but we're not necessarily interested in a straight average as we look at these total z-scores. Remember, we saw the z-scores that were made up of each individual data field, but now this is that positive representation average of those z-scores to try to give us some indication to a variety's performance across multiple locations, across multiple years, across multiple data fields. So you're really building a complex matrix view of these varieties and simplifying it down to an easy to understand format. So I can go ahead and I can sort my totals here for the 3 years across the ones that I've selected. And interestingly enough, I'm looking at Snowden and Lamoka here towards the top with these MSZ and the MSW varieties here in between. But let's say that I don't like this being a straight 1-to-1-to-1 average. Well, that's where I can come up here to adjust data field weight. And if I click on adjust data field weight, you can see that all of these are given a weight of 1. So let's say that in my particular case, I care about specific gravity twice as much as I care about everything else. And as you see, as I change that to 2, these started to update their values and reorder themselves. Let's say that defect external percentage, yeah, you know, it's important, but it's not that important to me because I can peel it away or whatever you want to say there. But internal is going to be a lot more important, so I'm going to bump that up. And you can see as I'm kind of changing these values here that these are changing over here. So I've now got this new weighted score average that I've applied. Now, interestingly enough, you saw these values all change, but it didn't really drastically affect the order in which these varieties are ranked. Depending on how many data fields you have selected, depending on the distribution of the data, as you change these weights, obviously those rankings will change. They just don't happen to in this particular case. And if for some reason let's look, you have your defect external here with a -1. Let's say, for example, you didn't want that value to be inverted, basically saying that the higher the value is worse and the lower the value is better. Let's say you wanted a high defect external, you could just click on this and invert that, and it would update the values accordingly. But we don't want that. We want to make sure that this is inverted because we're looking for the lowest possible defect percentages that we can. So what I could do at this point is, this is a very beneficial chart that I could throw into a PowerPoint presentation or something, but how do I get that? Well, simple. Come right over here to this image icon and save analytics as image. And when I would click on that, what it'll do is it'll resize it for you and dump a PNG file that we can see down here. And that PNG file then you can use to put in a report or whatever document that you want to use it for. So you have that ability. And the other option that you have up here is you can actually dump this all to Excel. So you have the ability to dump that and use this chart view somewhere else. And there's one more piece that you can do with this information now that we've got it where we want it, is you can actually say, all right, I'm going to select these top 4 varieties and I want to actually compare these more side by side. So all I did was I just clicked here either on the variety or in the blank spot over here, and I've selected those 4 varieties. You can see I have, 4 selected. And then I just come up here to compare selected varieties. And once I've clicked on compare selected varieties, it takes me now over to the compare page where I can see all of those varieties. And again, I have correlated data on, so this is where all of these varieties existed within the same trials. So I'm comparing them truly together, and you can scroll down through here and you can see how they all compare across all their values. If you're interested in knowing more about the compare feature, there's another video that highlights more of the details of the compare. So that's a quick overview of diving into some of the details that are a part of the analytics feature within Medius.Re.